Hello, brilliant scholars. We are getting ready for the Chapter 6 test, so I figured I will put together some practice problems that you guys can try on your own and then push play to watch me do some more. Just kidding. Let's start that again. No more interruptions from the cellular device. So the first question, it says to find the area. Now without a calculator, I'm going to try to do all of this without a calculator because your test next week is without a calculator. Maybe it's this week, whenever you're watching this, I'm not sure. Before I forget, I'm going to start embedding questions into this lovely video through another program. So when their little video or like a stopping point comes up, click on the right answer and then continue watching the video from there. And it's just a little checking for understanding. So I'm trying something new. I like trying something new, but it might not work out. So give me a little bit of wiggle room. Okay, so before I start, I need to go back to figuring out how to graph a sinusoidal function. So this lovely trig function here. I don't know the area it says is going to be with this function, the x-axis, and then in the fourth quadrant. So I need to know what this function is in order to figure out, am I going to be using horizontal cross-sections or vertical cross-sections? So I have to go back to my pre-calculus days and say, how do I figure out the period of a function? I know sine and cosine has a regular period length, start from the beginning all the way to the end of 2 pi. But if you start putting numbers in front of that x, it changes it. So at this point, how do you find the period length? Ooh. So I'm going to say that if I know the period length is b, I always take the original 2 pi and I'm going to divide it by the number that's around the x. Number that's around the x. So that's what alters it. So this is 2 pi. Division changes multiplication. Flip the fraction around. So then the pi's are gone and my new period length is 8. So if I were to graph this wonderful picture, whoops, I know I'm going to start at 0 and go until 8. And then if I cut it in half, that's going to be at 4. I can cut it in half again, get a 2 in there, and then it's going over by 2, so this last point is 6. The negative 2 in front, well, the negative is called the reflector, right? It switches over the x-axis, So instead of starting at 0 going up, down, down, up, we're going to start at 0 and go down, up, up, down. And then the 2 is the amplitude. The amplitude just stretches out the graph. So it'll go up 2 and down 2. And so because it is a sine function, we will start at 0, 0 and go to the next point and then up and lastly down. So we want to be bounded by this lovely curve. Ooh, la 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 la. Okay. The x-axis, so that's this portion, and we want only the portion that's in the fourth quadrant. So that will cut us off to just this section here. Okay. This portion up top is in the first quadrant, so I don't want that, so that's going to be my bounded region for this problem. If I was looking there, where does the y equals 0 and this function intersect? Where are the points of intersection? Those do look like those 2 points there, so I know that points of intersection would occur at 0 and at 4. So knowing this formula here, that it's 2 pi divided by the constant in front of the x, this lovely thing is going to help a ton to remember. Okay, so now we're going back to finding the area. Now that I drew the function, we have the x coordinates. Well, since I'm using the x coordinates, it must be a vertical line segment that I'm going to be connecting. It's always the y equals 0 that's on top, and then the trig function that's on the bottom. So I'm going to say it's top minus bottom. Top is 0. Bottom is that negative 2 sine pi over 4x. And then dx. We're not rotating anything, right? If we're not rotating, it's just top minus bottom. Okay, don't make it more complicated than it needs to be. Vertical line is going to be with respect to x, so I do top minus bottom. Remember, the x-axis equation is always y equals 0. So then I can say, well, I can go from 0 to 4, and then I can just simplify this guy now, right? The two negatives make a positive. You guys are totally fine with me writing it pi x over 4 versus pi over 4x, right? Multiplication, division of fractions, doesn't matter the order that you do it in. If you need to, please off to the side know that this will require a u substitution, that if I set pi over 4x is my u, then my du is going to be pi over 4 dx. Well, that pi over 4 needs to be undone because there's only a dx there. So I'm going to be substituting in a 4 over pi, right? 4 over pi to get rid of that portion. You can also think of it as, because this is a linear function, the chain rule would produce an extra pi over 4. So to undo that pi over 4, you are going to have to divide by pi over 4, or in this case, multiply by 4 over pi. Okay, so I'm getting better that I don't have to do the u substitution anymore. If it's a linear function, you just undo the slope, the number in front of x, and in this case, to undo it, you multiply by the reciprocal. I pulled the 2 to the outside. I have that lovely constant. The antiderivative of sine, finally, is a negative cosine. And I'm keeping the u the same. And I'm going from 0 to 4. Okay, so now I can plug it in. If I'm plugging in a 4, the 4's here cancel, leaving just a pi, minus cosine of 0. So a nice 4 was beautiful because it cancels out with the denominator there. Cosine of pi is -1. Cosine of 0 is +1. So that's a -2. -2 times -8. Oh, I did get a positive area. I'm not sure why I put a 2 there, because 8 times 2 is 16. Okay. So then there's your exact area. Now remember, it doesn't matter that this portion is located in the 4th quadrant. It is not going to be a negative area because it's bounded between two curves. In chapter 5, yes, you could get an area that was negative because it was just located underneath the x-axis. But when you have a bounded region, right, it's going to always be a positive area. So be careful. Make sure your answer does come out to be a positive. So we have the same thing now, but we want to now find the volume. So same functions. I can graph a little one over here. And I know that my points of intersection still be at 0 and at 4. And the shaded region is still right inside here. And now we're going to be rotating it about the x-axis. Okay, so if I'm rotating it, looks like that my radius is going to be all connected to the axis of rotation. So this is going to be a disk method. Okay, disk method. And I need to find what the radius is. Now don't get misled, right? That this looks like it's going to be a negative radius. That cannot happen. It's still going to be the top minus the bottom. Okay, top minus the bottom. So the radius of this, if the top is 0, minus a -2 sine pi over 4x, right? The two negatives do cancel out, so it turns out nicely that it is a +2 sine pi over 4x. Now because I'm finding a volume using the disk method, I'll have a pi r squared. So my 2 sine pi over 4x squared. I put the thickness, okay, as a dx, and I'm going still from 0 to 4. Now this problem you can't do anymore by hand, so if it was on the test, you'd say, or the problem would say, set up, do not solve to find the volume, and so then your answer would be complete there. If you had a calculator, you can plug it all in at that point and get your answer. So now we want to take that same function, bounded exactly the same, and then rotate it about the y-axis. Well, if I'm rotating about the y-axis, we're going to have a problem. Because if I were to draw perpendicular segments across here, it's not possible Because it's all one function. This is all one function, and you would need a longer radius and a smaller radius. So which method are we going to use at this point? If you can't use the washer method, you have to use the cylindrical shell method. There's another cellular divide. So the cylindrical shell method, if you're using it with respect to wrapping it around the y-axis, this is going to be your radius, and then we're going to make our cylinders go across, and then we find the height between the shaded region. So the height connects the shaded region, and there's one cylinder. Now the lateral area of one cylinder is 2 pi r(h), where r, like I said, is going the horizontal distance, and h is going up and down. Okay, and this is all going to be in terms of x, which is nice because this value here is already in terms of x. Awesome. So my radius is going to be the distance from the axis you're rotating to the function. Well, the axis you're rotating is at 0, and we're going horizontally, so that is an x distance. The height, once again, it's the top function minus the bottom function, same as the radius that was up top before, so it would be the 0 minus a negative, right? The two negatives make a positive. And I get the height to be 2 sine pi over 4x. Now I put it intentionally, this portion, in the denominator to show you that it will come out to be a positive radius every time if you think of this top function as your 0 minus the negative portion down here. Okay? And then once you do that, we're going to set it up. We're still in terms of x, so I will still be going between 0 and 4, right, the intersecting points. And then 2 pi r, our r is the x, times the height, and don't forget about the dx. And then that one, once again, it would be too hard to evaluate that by hand, so it's just going to say set up, but do not solve. The base of the solid is a circle with x squared plus y squared equals 1. Cross sections perpendicular to the x-axis are equilateral triangles. So these ones, it has to tell you, if you're using cross sections, we're not rotating, and it tells you which axis that you're perpendicular to. If it's the x-axis, everything has to be in terms of x. And then equilateral triangles are going to be the area of the shape that we're going to be creating. Okay, so for these ones, my general formula will always be a to b, the area of the shape, and then because it's perpendicular to the x-axis, I'll put a dx there. So we have this base. They're telling us that the base is a circle, so I'm going to go up 1 over 1 in every direction. Ooh, I missed. I'll do a little improvising. Okay, and so that is going to be the base of this shape. And then the equilateral triangles are going to be coming out of the graph, and we're perpendicular to the x-axis, so I'll draw one side length to be right there, and then we're going to be coming out of the graph looking like that. So if I draw it flat, I need to figure out what is the area of one of these triangles. I know the thickness is going to give you the whole dimensions of the volume. Okay, so that's going to be the dx, but I need to know what is the area of one of these. Well, if it's equilateral, this side length is going to be the same for all three sides. So if I figure that out now, okay, this x squared plus y squared equals 1 is for the whole circle, but hopefully you've ingrained it in your head that if you have a semicircle, you're going to have x squared or y equals 1 minus x squared on top to give you the positive portion, and then you get y equals the negative square root of 1 minus x squared on the bottom. So to find one side length, we do once again the top function minus the bottom function. Well, two negatives once again makes a positive. So those two negatives cancel out, and you're left with 2 times the square root of 1 minus x squared. Okay, so that's one side length. I'll put that right here. But the area we're looking for is 1/2 base times height. 1/2 base times height. Well, that could be this portion here as well, right? The length here could be the base. Now the height, though, has to be this perpendicular segment, perpendicular to the base. So I have to drop the height there. Now, since this is an equilateral triangle, all angles originally started at 60. I cut it in half to get 30. So if the whole thing is 2 radical 1 minus x squared, half of it is going to be just the square root of 1 minus x squared. And then if you remember that ratio, that it's x rad 3, and 2x to get your 30, 60, 90 triangle. This portion is x, so then this height would be rad 3 times radical 1 minus x squared. So to come up with the area, 1/2. The base is the whole entire length, so 2 times 1 minus x squared, times the height, rad 3 times, like that. So then I can simplify, the 2's are gone, the radical times radical of 1 minus x squared would be gone, and you're left with just rad 3 times 1 minus x squared. Okay. That represents the area of one triangle, but we want to take infinitely many of them. Now remember, we're going all the way across the circle, so I'll have to start at -1 and go until 1. And then it's going to be the area times the thickness. So rad 3, 1 minus x squared times dx. Please don't forget the dx across the test. Those are easy points. Now because this is symmetrical, right, I can cut it off at 0 if I wanted to, and just double the whole thing. Now I did have to find the whole entire length going down. You could not stop it here. Okay, it has to be the full triangle in order to do it, but because symmetry works with the shaded region, I can go from 0 to 1. So pull the 2 rad 3 out, anti-derive, so I get an x minus 1/3 x3, 0 to 1, and I get 2 rad 3, 1 minus 1/3, which is 2/3 times the 2, 4/3 rad 3 would be the volume of this shape. No calculator, awesome. Number 3, remember I'm trying to get you guys to try it on your own first and then watch it second. So don't just let me do all the work. You need to try too to get better and better at not only graphing but integrating, remembering your dx, all the wonderful things I tell you all the time. Ingrain it in your brains. Okay, so the bounded region is with the y equals rad x. Well, that is one of those square root functions. So I know 1, I'll put 2 over here, 0, 0, 1, 1. The graph looks something like that I missed the point altogether. And then with the x equals 0, which is the y-axis, and then the line, y equals 1. Ooh. So the bounded region is made up of all of those, so that looks like it's going to be going right inside here. So that's going to be the bounded region, and then we're going to be rotating it about x equals 2. So that's this line that we're going to be rotating it around. We want to find the volume. Okay. So we think, which method would be most convenient? Well, I don't know. I'm going to do the washer method, because I've done cylindrical shells, I've done the disc method, so why not use the washer method at this point since I haven't yet reviewed that. The washer method says you start at the axis of symmetry, axis of rotation, and you're going to go to the further out function. You're trying to create your longer radius. So there's going to be my horrible long radius that's going to be wrapped around, right? It has to go past the shaded region to the further out function. So the long radius I'm going to call is going to be right minus left. Right is 2, left is 0. Okay, and then the shorter radius is going to start at the axis of rotation and go to the closer function, which is right about there. So the short radius is going to be the 2, the right function, minus this lovely radical function. Well, the radical function is in terms of x right now, but because we're doing it perpendicular to a vertical line, we want everything in terms of y. So if I do the square real quickly, right, square both sides, I get x equals y squared. So my other function would be y squared. 2 minus y squared. And now it's going to be the long radius squared minus the short radius squared. Pi r squared, right, because it's circles. We want to be in terms of y, so I'm going to be going from 0 to 1, the points of intersection. And it'll be the long radius plus, oh, not plus, just kidding. Long radius minus the short radius. And then thickness is dy. So I can simplify a bit. I get 2 squared is 4. And then FOIL that out. I get 4 minus 4y squared plus y to the 4th dy. I'm going to cheat a little bit and distribute the negatives so I don't have to rewrite the whole thing. So minus plus minus, and then 4 minus 4 can cancel out, yay, and then integrate what's left over. So we're going from pi, I get 4/3 y3 minus 1/5 y5, and I'm going from 0 to 1. Pi 4/3 minus 1/5. And then minus 0, I love zeros, they're wonderful to plug in. 20 minus 3 is 17 over 15 pi. So there's your exact answer. You're probably wondering, how'd you do that fast? I call it zip, zap, zoom. You multiply the cross to down, so that's 40, minus, because it's a minus sign, multiply up. So this is a zip, this is a zap, and then the zoom is just finding the common denominator going across. It's pretty good. Okay, so then there is the bounded region. For all you overachievers out there, if you do want cylindrical shell method, I will set it up, but I will not integrate it. Let's see here, I haven't used pink yet. So to do the cylindrical shell method, you're going to have to go from the axis of rotation over to whatever function you want. Okay, because my cylindrical shell is going to be going off the page for one, but that's the base. Okay, the height has to be connecting the shaded region together. And then there's the top part of this cylindrical shell. Okay, imagine it did go off further, equal distance. Okay, so the radius is here and the height is here. So what we want to call the radius, this distance over here is considered x because you're starting at 0 and then it hits the function is x. And then this whole entire distance across is 2. So we still do right minus left. So the radius would be 2 minus x. The height is going to be the top function minus the bottom function. Because the cylinder is perpendicular, it's sitting on top of the x-axis, we do want everything in terms of x. Remember, if we did the washer method with y's, we're going to use the cylindrical shell method with x's. So then I can go back to this equation. Well, the top function, first off, is 1, minus the bottom function, which is rad x. Okay, points of intersection in terms of x are still going from 0 to 1, so that doesn't change much. And then it's 2 pi r, r is the 2 minus x, times the height, which is 1 minus rad x, and then to make it into a volume, you do dx. Boom. Chuck, 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 chuck. All right, Next one, it says let t of x equal that lovely function, exponential function. Find the temperature of coffee in degrees Celsius. Oh, let it be the temperature of coffee in degrees Celsius after x minutes. What is the average temperature? Well, if it's asking you for average temperature, right, it's asking for average temperature. We are looking for the mean value theorem for integrals. Because all exponential functions are continuous, I can apply the intermediate value. What did I just say? I can apply the mean value theorem of integrals to this function. So what does that say? We want to find some c value, that is your average value. I should say some t value, t of c, there we go, such that we divide by the interval. How long is the interval? Well, careful with your units. If it's asking for minutes, I don't want to use a half, right? A half, nope. I want in minutes, so a half hour is the same as 30 minutes. So I say 30 minus 0, because you start at 0. And we're going from 0 to 30 of our function. Okay, and don't forget the dx. So to integrate this lovely function, 20 is going to be 20x, and then plus 75 just goes along with the right, it's a constant. E to the anything stays e to the anything, but because there's numbers around the x, right, we're going to have to use that undoing property, or if you want to make a u substitution, you can. Okay, if your u is negative x over 50, your du is going to be negative 1 over 50 dx, right? I want to solve for the dx, so I'm going to multiply both sides by negative 50. Remember that rule I told you before? Once you start getting really good, if your u is a linear function, the slope to undo it, right, is going to be what we're multiplying by. So if the slope here is negative 1 over 50, we're going to multiply the whole thing by negative 50. Do I get the same thing by making the u substitution? Yes, but please remember, if you have any numbers around the x, you have to undo it with integration. 0 to 30, and then you can plug in the 30. 20 times 30 would be 600, plus, I guess it would be a negative because of that minus sign in the back, 75 times 50, e to the negative 30 over 50, minus, yes, that portion cancels out. You are still subtracting, so that turns into, oh goodness, it is a minus, and then we're subtracting, so it turns into a plus. 75 times 50 e to the 0 power. Okay. Don't always think that the 0 is going to cancel everything out. If it's exponential, it turns into 1, right? So the constants in front are going to stay for the right. I don't have a calculator besides that, so that would be my answer from there. Average temperature, you take the area under the curve, and then you're going to divide it by however many minutes in this case we're going to be traveling or waiting or whatever. All right, number 5, it might look familiar to all you wonderful extra credit kids out there. Let dy over dx equals 3 minus y cosine x. Now, my question to you all is, what does this represent? What is this in layman's terms? Easy way? Yeah, that's right. It's just the slope. Right? If it's just the slope and it asks you for an equation of a tangent line, don't get all fancy on me. All they're asking you for is an equation of a tangent line. That means you need a point and you need a slope. Well, this is the equation for the slope, and here's your x and here's your y. So no, do not plug in the x and y's to the m. They want a numerical value. You can find a numerical value by plugging in the 1 for y and the 0 for x. So this is a 2, cosine of 0 is 1, so my slope is 2. Okay, so then the point I can plug in as well. Y minus 1 equals 2, x minus 0. Okay, so the slope of a line, the equation of a tangent line to whatever the actual curve is. Yes, this is going to have a y equals something, blah, 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 once you integrate. But if they're asking you for just a tangent line, you're just writing an equation of a line. I like point slope form. If you'd rather slope intercept, go for it, okay? But read the question carefully to answer it right. It'd be a shame if you switch these two parts around, because then it's completely wrong. You didn't answer the question, either question correctly. Okay, so now the next part says find y equals f of x. Now it's saying not specifically find a linear equation, right? An equation of a line. A line means you have this form here every time, where it says just find y equals f of x. That's the particular solution. That's when you're going to integrate. Okay, so the first step is to separate. Then you're going to integrate with the plus c, and then you're going to solve for y. Okay, so if you want to think of these differential equations in that form, separate the variables, integrate both sides, remember the plus c, and then solve for y. Good job. So I'm going to take this lovely thing. It looks like I only can multiply or divide, so the 3 minus y needs to go to the other side. Because it started on the top, I'm dividing it over, so it goes to the denominator on the other side. And then over here, I'm going to multiply the dx up. I still laugh at myself because with my hands that you can't see, I'm saying move the dx up, and I'm pointing to the cosine x. Yes, I'm strange. Okay, so then I get my variables separated. I can integrate both sides. Please, 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 this is a linear function on the bottom, so either use a u substitution or know that the slope of this line is -1, so I have to undo it. I have to undo it with either multiplying or dividing. Because it's a -1, it doesn't matter which one you do. Okay, but 1 over anything will always produce ln of anything. And then over here, please remember your absolute values. Those are important. The antiderivative of cosine is sine x. And I remembered the plus c. So to get the points on this problem, you separate the variables for 1 point. You integrate both sides correctly. That's 2 points. And you write the plus c as the 4th point right there. Remember, we're averaging 4 points per every FRQ. You got the 4 points right there. That's awesome. So you can like spread out the average for the other points. The other questions, you had no idea how to solve. Okay, so from here, I'm going to plug in the x and the y. So I get negative ln 3 minus 1 sine 0 plus c. And then now some people are debating, like, I got this C number and another person in my group got a different C number. It all depends on when you plug in the numbers at what point that you will get different C's. But as soon as you go back up and try solving for y, you will get the same value at the end. Okay, so sine of 0 is 0, so C is equal to negative ln. This produces a 2, so I don't need the absolute value, so I can just write 2 there. Okay, because I don't need the absolute values, I don't need to worry about changing any signs later on. Okay, so I can go back over here, plug in the C value that I got at the point where I got it, plugged in the points from. And now, instead of moving the negative to the top, I want to solve for y, so I don't want to move y to the denominator. So I'm going to multiply every single term by -1 at that point and get ln of 3 minus y equals negative sine x plus ln 2. So some people might have multiplied by -1 before they plugged or found c, and then they found c to be a positive one, or a positive ln 2. Like I said, they're not looking for the actual c value you got. They're looking that you found c, you found a c correctly in your whatever method, and then you solve for y correctly. So from this step, I raise both sides to the e power. Notice ln here has a positive 1 in front. That's the only time that ln and e will cancel, bringing the 3 minus y down. Over here, because of the plus sign, remember that theorem that says x to the m times x to the n is equal to x to the m plus n? Okay, because the bases are the same, you can add the exponents. Well, now we're adding the exponents, so I can rewrite this as e to the negative sine x times, I'm just going backwards, writing two different ones, e to the ln 2. Well, that's nice because now it has a coefficient of 1, so the ln of, or e to the ln cancel, leaving a 2. And then now, because, remember this step over here that I said 3 minus 1 is 2? We don't need the absolute values. I can finally take that out of the absolute value sign without having to change it. If I did need to apply the absolute value at this time, I would have to change both of these signs in order to always make it positive, because we're in the negative land, the negative region. So then that's 2e to the negative sine x. Flip-flop these two signs around, and I get 3 minus 2e to the negative sine x as my final answer. Okay, so like I said, we had 4 points before. You found one c value at whatever point. It could be different. They would follow your work to see if it was consistent. So that's 1, 2, 3, 4, 5. And then solving for y correctly and getting this answer would be the 6th point. All right, guys, way to go. What other tips for the trade? I think that's it. Okay, so if you're still wondering, go back over the practice tests that I gave you. You can go over any previous homework assignments. The Go Formative is a good tool to look at as well. The more practice you get involved, the better you're going to become.